Local LLM infrastructure and deployment. The Llama.cpp server has gained a significant new capability that brings it closer to feature parity with Ollama, router mode. This architectural change allows a single server instance to manage multiple AI models simultaneously without requiring restarts when switching between them. Previously, running different models, say, a lightweight one for basic chat and a larger reasoning model for complex tasks, meant juggling separate server processes, each consuming its own memory and port. Router mode consolidates this into a unified system where models load and unload on demand, with requests automatically routed to the appropriate model internally. The community quickly drew comparisons to LlamaSwap, the existing solution for model management. The key distinction: LlamaSwap operates at a higher level, capable of swapping between different inference engines like Llama.cpp, VLLM, and SGLang, while the native router mode is limited to Llama.cpp itself. For users with straightforward needs, router mode offers a simpler path. It integrates directly with the Llama.cpp web UI, auto-discovers models downloaded with the HF switch, and provides a drop-down for starting and stopping models. Power users wanting fine-grained control over concurrent model loading, per-model offloading configurations, or multi-GPU VRAM management may still prefer LlamaSwap's flexibility. Running DeepSeek v32 on consumer hardware has proven challenging, with the community still waiting for full support in VLLM and Llama.cpp. The breakthrough came through SGLang's implementation, which handles DeepSeek sparse attention differently than VLLM. Where VLM forces use of the FlashMelee sparse backend, locked to enterprise SM90 Hopper and SM100 Blackwell GPUs, SGLang's NSA backend dynamically selects kernels based on hardware availability, falling back to TileLang reference kernels when FlashMLA isn't supported. This means RTX 50 series cards, SM120, can actually run the model, achieving 65 to 70 tokens per second with up to 88K tokens in KV cache across 4 GPUs. On the memory efficiency front, REAP, redundant expert activation pruning variants of MoE models are gaining attention. One user reports running a pruned Qwen 3-coder 30B A3B variant at roughly 10 GB instead of 17 to 18 GB at Q4 quantization on a 2023 M2 Pro MacBook with 32 GB RAM, enabling 100K token context windows where the original model topped out at 40K. The technique identifies overlapping experts in MoE architectures and removes redundancies, while reportedly preserving quality for coding tasks. Local models are also finding their niche as judges in AI agent evaluation frameworks. A new tool called EvalView allows using Ollama models to evaluate agent outputs, checking whether responses used correct tools and produced sensible results, without burning cloud API credits. The economics are compelling for iterative development, though one benchmark visualization shared in the discussion reveals a crucial caveat. LLM judges exhibit high variance, with some models being strict evaluators and others extremely lenient. The practical advice: treat local judges as cheap, noisy filters for rapid iteration, then validate with stronger cloud models for production decisions. AI-powered development tools and coding assistance. A new open-source project called Ghost aims to automate the QA testing workflow entirely locally. The autonomous agent writes and fixes unit tests using Ollama-hosted models like Llama 3 or DeepSeek, though it also supports cloud APIs for users who prefer them. The tool installs via pip install Ghost test, and positions itself as a fully local alternative to cloud-dependent testing assistants. The community response included some skepticism about Ollama's continued prominence. I can't believe anyone serious about local is using it, though defenders note that any OpenAI-compatible server can be pointed at port 01434, making the Ollama dependency effectively optional. The broader conversation around AI-assisted coding continues to evolve toward more intentional practices. A thoughtful post argues that with code on tap now available, the fundamental nature of programming is shifting. Developers can spend more time thinking and less time translating thoughts into syntax. The author's practical advice distills to a planning prompt workflow: draft a plan, verify it, then implement, with the intensity of planning scaling to task complexity. For simple changes in familiar code, vibe coding works fine. For complex features in unfamiliar territory, religious planning becomes essential. The key insight: AI doesn't fundamentally change software engineering best practices, but it makes investing in them dramatically more important. Context management remains a persistent pain point for developers working with Claude on large code bases. A detailed discussion thread reveals multiple strategies the community has developed. The most sophisticated approach involves spending significant time documenting the codebase into small markdown files, under 500 lines each, organized into logical directories with glossary files and cross-references. One user claims this investment results in Claude effectively coding as well as most mid-level engineers and autonomously fixing bugs. Other approaches include phased planning with markdown checkboxes, disabling unnecessary MCP servers to preserve context, and using subagents to generate context on demand rather than maintaining static documentation. Direct model comparisons continue to show Claude Code maintaining an edge over OpenAI's offerings. One developer ran a weekend test rebuilding website sections using both GPT 5.2 via Codex CLI and Claude Opus 4.5 via Claude Code, with identical specs, branding guidelines, and component libraries across 7 parallel tasks. The result: not a single Codex branch was committed, while Claude delivered code I could ship every time. The diagnosis: when specs had gaps, as real-world specs inevitably do, Claude understood intent and filled them in, while GP 5.2 produced half-baked solutions that would have taken 5 to 10 follow-up prompts to fix. The post questions whether OpenAI leadership is really that out of touch, given the rushed releases of both 5.1 and 5.2. AI security vulnerabilities and safety research. Anthropic, working with the UK AI Security Institute and the Alan Turing Institute, has published sobering research on LLM training data poisoning. The headline finding: it takes only approximately 250 carefully crafted poison pill documents to compromise models ranging from 600 million to 13 billion parameters, a threshold measured in parts per million rather than the 1 to 2% of training data researchers previously estimated. The specific attack tested triggered gibberish output when users included the word pseudo in their queries, effectively rendering poisoned models useless for Unix POSIX command line assistance. The implications extend beyond denial of service scenarios. The research raises an uncomfortable question. If a tiny number of documents can force gibberish, could an equally small injection trick models into producing dangerous code or medical misinformation? Previous research has already demonstrated that shockingly small amounts of misinformation in training data were sufficient to ruin medical models. The attack surface is particularly concerning, given that much LLM training material comes from aggregated web content of varying quality. Community discussion highlighted another practical limitation. LLMs fundamentally cannot do exact quotes or link content to sources, meaning reference links in AI outputs are often unreliable regardless of poisoning. Google's Anti-Gravity IDE, launched as their agentic development platform powered by Gemini 2.5 Pro, received a critical security disclosure within 24 hours of release. MindGuard researchers discovered that a malicious, trusted workspace can embed a persistent backdoor executing arbitrary code on any future application launch, even when no specific project is opened. More troublingly, this backdoor survives complete uninstallation and reinstallation of anti-gravity. The vulnerability persists even in the most restrictive Ask security setting, and the trust model inherited from VS Code breaks down. Marking a workspace untrusted renders anti-gravity's core AI features completely inert, effectively forcing users toward dangerous defaults. On the evaluation and safety front, a collaborative effort has published a v0.1 white paper addressing agent reliability measurement. The core argument: current AI evaluation remains capability-oriented rather than deployment-oriented, rarely testing boundedness, robustness to environmental variation, user control requirements, confidentiality, or adversarial resilience. The proposed solution is a maturity ladder taxonomy progressing from research-grade evidence through bounded, controlled, confidential, robust, and secure agent behavior toward genuine reliability. The working group spans industry labs, academia, standards bodies, and practitioners, with even arriving at shared definitions requiring a surprising amount of alignment work. Section: Efficient Small Model Innovations. The tiny recursive model has sparked debate after reportedly surpassing DeepSeek R1, Gemini 2.5 Pro, and O3 Mini on specific reasoning benchmarks, with only 7 million parameters and a training cost under $500 on two H100s over 2 days. The architecture employs a recursive reasoning loop. Draft an initial answer, build a reasoning scratchpad, compare logic to find errors, revise and repeat up to 16 times. Each task costs less than 1 cent to run. The catch, as commenters quickly noted, TRM solves ARC-AGI 1 and 2, Sudoku, and maze tasks specifically. It can't generalize in any tasks, and doesn't even speak English. It's essentially an unrolled RNN refinement model trained with supervised learning on grid-related problems. While the learned refinement concept could prove interesting for fine-tuning larger models, applying similar techniques to a 20B model would be prohibitively expensive, likely requiring LoRa adapters with early exit or distillation. The broader takeaway isn't that tiny models will replace frontier systems, but that architecture-first thinking, rather than pure scale, is driving important advances in specific domains. NVIDIA's Nemotron 3 Nano 30B A3B represents a more practical efficiency play, targeting the emerging era of multi-agent AI systems. The architecture combines a hybrid Mamba 2 and Transformer mixture of experts design, with 31.6B total parameters but only approximately 3.6 active per token through MoE routing that activates 6 of 128 experts per forward pass. It supports context windows up to 1M tokens and offers configurable reasoning modes, on-off plus thinking budget, for predictable inference costs. Performance claims are substantial. Up to 4x faster than Nemotron Nano 2 and 3.3x higher throughput than Qwen 330B in an 8K input, 16K output configuration on a single H200 GPU. The release includes open weights, 3T new pre-training tokens, 13M post-training samples, and 10 plus RL environments covering 900K plus tasks. Multimodal AI and creative applications. ViaNu TTS, a Vietnamese text-to-speech model, has reached stable completion after roughly a month of development and community feedback-driven tuning. The results are impressive for a language-specific model, a 92% naturalness score compared to human speakers and 99% intelligibility, effectively eliminating common TTS issues like dropped or slurred words. The project promises GGUF and AWQ versions later this week, along with public LoRa fine-tuning code so users can train custom variants. Community responses included comparisons to existing Vietnamese TTS samples, with some arguing the field still needs better Vietnamese datasets to reach the quality levels of more resource-rich languages. For multi-person talking video generation, AnyTalker from HKUST C4G offers an audio-driven framework with a flexible multi-stream architecture that scales identities while maintaining inter-identity interactions. The 1.3B model checkpoint, trained exclusively on single-person data, is available now, with a 14B version coming to a creation platform. The system handles the complex challenge of generating coherent video when multiple speakers are present. Image editing sees 2 notable releases. Eigen-Banana Qwen Image Edit is a LoRa checkpoint for text-guided image editing trained on Apple's Pico Banana 400K dataset, roughly 400,000 text-image edit triplets covering 35 edit operations. The dataset spans semantic categories from object-level edits 35% to human-centric modifications 18% to stylistic transfers 10%, with automated quality control via Gemini 2.5 Pro. TwinFlow takes a different approach to efficient generation, creating an internal twin trajectory by extending the time interval to create self-adversarial signals directly within the model, eliminating the need for external discriminators or frozen teachers. This one-model simplicity enables 20B full-parameter training without the memory overhead of maintaining 3 separate models for distillation. Apple's iOS 26.2 release patches more than 20 security vulnerabilities, with 2 being actively exploited in the wild, a clear signal for immediate updates. The release also brings new features including alarms for reminders, lock screen changes, and enhanced safety alerts. Meanwhile, iOS 26 code analysis has revealed upcoming products: an Apple Smart Home Hub, AirTag 2 with 4 new features, and hints of an Apple Studio Display 2 with 120Hz ProMotion, HDR support, and an A19 chip. User feedback on iOS 26 has been mixed, with reports of visual glitches and accessibility concerns, including one case where a legally blind user's mother cannot use the new version. The economics of online manipulation have been quantified by the Cambridge Online Trust and Safety Index, COTSI, tracking real-time pricing for fake account verifications across 500-plus platforms globally. The price disparities are striking. Japan averages $4.93 per SMS verification, while the UK costs just 10, nearly as cheap as Russia at 0.8 cents. Platform-specific averages reveal Meta, Grindr, and Shopify at 0.8 per verification, while WhatsApp maintains consistently high prices at 1.2. The research exposes how SIM farms mass-produce fake accounts, with highest stock availability for X, Uber, Discord, Amazon, Tinder, and Steam. The dependency on phone numbers and SIM hardware creates what researchers call a choke point for understanding the hidden economics of online manipulation. For developers working with SQLite, Lightstream VFS introduces a compelling capability, running SQLite directly from object storage URLs without downloading the entire database. Loading the shared library and opening a file with the Lightstream VFS allows queries against S3-backed databases, with the system fetching only the pages needed for each query. The feature supports instantaneous point-in-time recovery via SQL pragmas. Pragma Lightstream time equals 5 minutes ago lets you query historical database states immediately. The implementation builds on LTX, a transaction-aware page shipping format that enables compaction for efficient page retrieval from backup files. Specialized AI research applications. Signature forgery detection remains a challenging biometric task with applications in banking, identity authentication, and legal documentation. New research from Pola UFRJ tackles the fundamental limitation in current systems: cross-dataset generalization. Most offline signature verification models perform well when trained and tested on the same dataset, but fail catastrophically when tested on signatures from different sources. Different populations exhibit different signature characteristics that confound single dataset training. The research employs Siamese neural networks with a ResNet-34 backbone, comparing pairs of signature images and learning embedding distances that reflect similarity or dissimilarity. Training uses both contrastive and triplet losses across multiple datasets, CDAR, IDAR, GPDS synthetic, with cross-dataset testing. Train on 2 datasets, test on the third. This approach forces the model to learn genuinely transferable features rather than dataset-specific patterns. The work includes a pre-processing shell algorithm for noise removal and dimension standardization, with AUC, area under ROC curve, as the primary performance metric. On the automation front, Maya MCP brings Android device and Windows desktop control to AI assistants through the Model Context Protocol. Built on Maya framework, the MCP server exposes automation capabilities to Claude and similar assistants, enabling natural language commands like "Help me connect to the Android device," "Open Meituan and order takeout for 1 person, Chinese food, around 20 yuan," or "Look at my current PPT slide and show me how to add a rotation effect." The project demonstrates how standardized protocols can bridge AI reasoning with real-world device control.